basic library we need to call first. That is, just click on the view and there toggle line number. Click on toggle line number, you will get all this line. Okay, so we will take the some means even you can take the data from GitHub also, but directly from the raw link. And I will take the data which is available for just for the practice purpose inside the SNS. So when you pass, I think load data set, okay, and there some data is available. Like if I pass the tips, you will get the tips related data, okay, and I will assign this as a data, so I can use means as a variable that entire data set. Okay, so when we talk about the any means data set, there some column will be available, and that column is nothing but the variable in short, you can say. And that variable sometimes it is numerical, sometimes you will get in the form of the categorical type. Okay, so now for category type of the data, there is the different stats techniques, and for numerical data also there are different stats technique to deal with those data. And now suppose I want to see means for every data, first you need to check, okay, what is the distribution of that particular data. It is a left skew, right skew, or it is a proper normal distribution or not. So that all the thing you need to check. Okay, so now suppose first if I take okay, so like total bill is the continuous data, and with respect to the continuous data only you will talk about the normal distribution. Okay, when I say the categorical type of the data, their distribution will be, you will get like Bernoulli distribution and all that. We will discuss the some theory part, but even you can also means you need to explore all these things. Even I told in the previous sessions also, you need to explore what is the what type of the distribution is available, why it is required, all the thing you need to explore. Okay, so now here I want just this total bill related thing. Okay, okay, I will take, so how I can call the total bill with the help of the square bracket and just pass the name of the total bill variable name. Okay, so now if you call, you will get only data with respect to the total bill. Okay, now I want to see what is the distribution of this particular data. So you can see that distribution with the help of the distribution plot, as we discussed in the data visualization part. So this is the entire one variable, right? If I pass this variable in the disk plot, I will get the distribution plot. So how I can do that particular thing? This is the my data, means assume that this is the A, means just one column, okay? And I will pass this particular thing into the SNS dot disk plot. Okay, this is the entire variable I will pass into SNS disk plot, and I will get the distribution plot. So there's some warning you will get, that is not an error, but now you can see it is a actually, you can say this is the what type of the data, right skew or left skew. It is a right skew data. Okay, and how to check even with the help of the this means skewness also, means with the help of the skewness number also you can measure. Keep positive, then you can say right skew. If negative, then it is a left skew. Okay, so now I will show the code, and you can ignore this warning. How to ignore that, I think we discussed in the previous session. Import warnings, and you can pass then warnings, then filter warnings, and you can ignore this part. Now you will get the graph without warning. Huh. So here means when continuous distribution, they are very famous. One is the normalized normal distribution, and it is actually means drawn on the basis of the central limit theorem. So maybe I think you go through the central limit theorem. What is the central limit theorem and all part? Okay, and even I will give the some basic idea here. Okay, what is the central limit theorem? Once we start the continuous probability distribution. Okay, so before that, one we try to do the means this what you can say discrete probability distribution. So there is the one is the binomial distribution. Okay, so what is the thing here? This is the condition. The experiment should consist and repeated trial, means just assume that you have the coin, and if you flip the coin, you will get the two output. So always if you have two output, like one is the success and one is the failure, so it will come into the binomial distribution. Okay, so like that again you can consider when you see the means when you get the, if you work in the manufacturing industry and you means order the some assembly part, okay, and you will check your, it is a defective or not defective. Only two outcome, in that case you can say that is the binomial distribution part. Okay, the next each trial result just two possible, that already I told, means you will get always two output, success or failure. Okay, and the probability of success you can denote by p, and failure means 1 minus p, simple. So the trial are independent, means it is not dependent, means even if you say the, if you means toss the coin, you will get the head and tail, but both are independent. Okay, and okay, so this thing means suppose just assume that there is the one coin, and if I take the Okay, so suppose if I means flip the two coins simultaneously. Okay, so what is the chance in both coin I will get head. One chance is if I will get head tail, even tail head or tail tail. Okay, so now I just want to know what is the chance of head. Head is just assume that success and tail is failure. Just assume that. Okay, so in that case, how many chance I will get the zero head? Zero head means here TT means zero head. So there you can say the chance is one and total number of possible thing is four. So here probability is 1 by 4. Okay, the same how many chance I will get one head. So one head means here means head you one head I'm talking about. So two possible thing. Okay, so 2 by 4 half. So you are getting the output is half. And the next one, what is the chance I will get two head? So there is only one possible thing out of four. So that's why it will be 1 by 4. Okay, so how to use this particular thing that we try to do now. Even we will take one example also in the Python we try to do now. Okay. Okay, so import numpy already we done now. Okay, so now just assume that okay, so I will take I just try to do the that particular experiment 10 time. Okay, so that how we can simulate inside the Python that we will do now. So here np and I will pass the random and the output when I toss the coin, it is a discrete probability distribution. So always you will get the output in the form of the integer. Okay, so I want to create the random integer. You can say okay. Now, how much I want to create? Their chance means 0, uh, 0 to 2. Just assume that. Okay, 0 to 2 means why I'm writing 0 to 2. It will consider 0 and 1. Okay, so 0 to 2. And how many time I will do that particular thing? Flipping just 10 time. Assume that. So this is the data. Means this is a random data. Hmm? Means when I just assume that you have one coin, and when I flip the coin, there is the two output, right? 0 and 1. So I return 0 to 2. So it will give output always 0 and 1. 2 will not consider. Okay. Now 10 times. So it means if I put 0, 3, then take 0, 1 and 2. 0, 1 and 2. Because random is array is giving us only the chance of success. No, no, here 1, 0. 1 means just assume that head and 0 means 10. So both the thing it will give. Okay, this is the simulation means just. Just saying like what will be the result of 1, 1, 1? It's 10. It's not 20. Here में क्या है ना sir? No, I'm let's say if I assume that this is flipping of a coin and assume 0 is head and 1 is tail. So ये 1 आया तो मतलब I'm assuming tail आया. फिर next में head आया. Next time you can एक एक आंसर देगा. Yes, yes. Outcome देगा. Means yes, you can say like that. So how it is calculating the output की पहला head ही आएगा? No, that is the random ना. It is not. This is now again change. Means if you run again, it will change. Again give something. Okay. Now you can see. अच्छा हर बार simulated है ना? I'm just simulating the thing means it is random ना. So every time it give us a new. Obviously means when we flip the coin, every time it will change. Okay. Now 10 times means it is a just you can even write here it is a flipping coin 10 times. Okay, this is one simulation. Now one we can do. Okay, how to means deal with this, that also we will discuss. But suppose if you would have two coins, that also we will explore. So now suppose there is a die. Okay, and in die what is the chance? I think 1 to 6, right? So how to simulate that particular thing? The same code I will paste and 10 times just assume that I will roll the die. Okay, so what I will pass, you required 1 to 7 means 1 to 6 always you will get. I'm sorry, 1 to 7 means 1 to 6 output always you will get, right? And total 10 times if I roll that particular die, even you can write here roll a die 10 times. Then this is the output. Sometime 3, sometime 5, sometime 1, like that you will get. Okay. Okay, so now just I want to see when this type of the means thing, okay, discrete probability distribution, what type of the graph I will get. Okay, their chance of the each means event is same, so you can say there I will get the uniform distribution, and that we try to visualize now. Uniform distribution only you will get, right? It's because chance of the each occurrence like 1, 2, 3 is equal. So that we try to do now. Just assume that okay, so now just I try to do this particular thing 10 times. So in 10 times I will not get the uniform distribution because I need to play this particular thing approx 10,000, 20,000. Then if I visualize, then I will get the idea. The chance of the each event is equal. Okay, so that also we try to do now. Means now we are just doing the experiment. Then we will go for the theory and try to see if both are matching or not. Okay. So okay, now if I take np dot random and again it is a means discrete probability distribution, so integer always you will get, and 1 to 7. But now I will take the experiment, just assume that 10,000, then it will give the idea of the distribution. Okay, what means chance are equal or not, that idea I will get. Okay, so now you can say okay, so this is the thing, and what is the output you will get there, means this total, if you see the length of this particular thing, you will get the approx 10,000. Okay, now how to visualize this particular thing, that also we discuss in the SNS, right? Means here if I pass a is equal to this, and what I will do, SNS their count plot is available. Okay, and there if I pass the a, now you can see 127 1 minute 17 np dot random and int. I'm getting like this. Okay, x is equal to
On which access to
x is there is standard, there you need to pass, no? That is the one standard. If you go inside,
all are equal to
uh, so now you can say ki approximate you will get all the thing equal, so that it is a uniform distribution. Okay,
This is for which one? You're passing A, which is the output of ranking 1, 7,
10,000 times if you roll the dice, the possibility of all the 6 numbers coming in is almost equal.
almost equal, it is a uniform distribution.
After discrete distribution now has become converted to common distribution. Conversion. इसको central limit theorem भी बोलते हैं.
No, this is the means just discrete, how it means when we talk about the continuous, their chance it will be normal distribution and all. When I talk about the discrete, you will get the uniform distribution. Okay, there again many distribution in the stats, but when we talk about the die and this coin related thing, you will get equal chance for all the thing, right? So now how to means, okay, this also I will explain.
Just pass A. It didn't give. Then x is equal to A is.
There x is the standard they mentioned. When you pass the data, x you need to write. Means that is the thing. So that's why I wrote.
So does this not mean that like if the number of trials are very large, then your even your discrete distribution becomes normal?
No, normal distribution it will not, because normal is the continuous. Huh? Here we are talking about the discrete data. 1, 2, 3, 4, 5.
So
Normal means 1.1,
So
1.2.
the conclusion क्या हुआ कि when the repeated trials are very large, then the chance of fair and equal becomes.
Means that is the theory. When I toss the coin, there is a 50-50% chance. But actually, it is means same or not, that you can simulate with the help of the software. That is the one part.
So,
When we will, yes.
sorry, sorry.
No, ask. No.
So if you change the axis y, then it will become horizontal. That also we can do. In x, if we say y, then it's also.
No, it is a univariate, na. So 1 minute. I need to think. That means need to go inside the. Okay, just pass. Maybe it will work. Horizontal.
Basically, x is by the axis.
But you have to specify.
We need to specify.
Just if that, so it doesn't know where to plot it. So आपने कैसे किया था अभी? Go into that. इसके बारे में पढ़ना हो तो उसको देखना last time. Count plot में जाकर double.
SNS dot and press tab, you will get the all type of the thing. So their count plot is available.
Sir, about this,
Okay. Inside function, na. So when you go means go to the inside function and then press shift tab. Then again click here. Then entire thing how they made entire function, na. They give the means some detail. Okay, and if you want more detail, then go to the documentation part of the SNS. See what, then you will get more detail. Now. Okay, so now we try to means just one question is like that. If 2 die we roll, okay, and what is the chance means the sum is greater than 7, that we try to identify. Okay, if I roll the 2 dice, okay, the summation of that output is greater than 7, what is the chance? दोनों का addition. If I roll the 2 die, okay, so at 1 die I'm getting 3 and second die 2, it means less than 7. So what is the chance ki I will get greater than 7? Okay, so that is means biologically also we can say approx 0.5. But what is the exact means if you want to go towards more accuracy, then we need to do some simulation. So that we try to do. Then we will take one real life example how we can implement all this thing. So that I need to write. Okay, sum of 2 dice is 7. What is the chance that I want to? I will not write the entire thing. And when you do with the theory, when go through the theory, and you will get the idea. Okay, what is the chance? So you will make the permutation combination, right?
It's more than 7 and 7.
More than 7. Okay, more than 7. I will. 7. So what you did in the earlier in the means even when you measure there in the theory, what it will say, the chance of getting means from first die is you will get always 1, 2, 3, 4, 5, 6. Okay, in this is the just assume that die number 1, the die number 2, there also you will get 1, 2, 3, 4, 5, 6. Now if you make the combination, how many total combination you will get? 36, right? 6 into 6 means you can say one combination you will get maybe 1 1, you will get maybe 1 1 2 1 3 1 4 1 5 1 6, then 2 1, like that you will do. So 36 combination you will get, and in this 36 combination the 15 combination is greater than 7. Okay, so that means that is the theoretical part. So 15 by 36 and you will get approx 0.41. That is the theoretical answer. Now we try to do okay, it is valid or not with the help of the some simulation. Okay, okay, so this I will put in the comment section. Huh. So now what I need to do, I will create the simulation. So just assume that this is the die 1, and what will be the chance means np dot random, as you know. Okay, and always you will get the output random int. Okay, and there 1 to 7 I will get, and just assume that the total is 1 lakh. Just assume that. Okay, 1 lakh time I will do, and die 2, there also I will do np dot random dot 10,000 time I am rolling the die 1. 1 lakh. Even you can pass 10,000 also. 10 means if I take large size, then means I will means more accurately I will simulate. That is the point. Means your result will be more accurate in that case. If sample size is small, in that case you will not get that much accurate result. No? So that's why I'm trying to take the larger size. Now here also you can pass a random integer, and again 1 to 7, and again 1 lakh. This is the 2 die I will roll. Okay, and now what is the die sum that I will see? Okay, die sum is equal to what? Is equal to, you can say, die 1 output plus die 2, right? This is the die sum. Okay, and now if you see what is the die sum, you will get the output. Okay, this is the output, but here you will get the dash dash because it can't means show entire 1 lakh value. If you see the length, then maybe you will get the idea how many number of the data present inside this. That is the 1 lakh. Okay. Okay. That is the addition of these two. That is just addition of die 1 output and die 2 output, and that we require.
Running it by just typing that.
Now how many time we did this particular thing? You can say total 1 lakh time, right? In 1 lakh time, now I will see. Okay, this sum is.
How many times that's greater than 7?
That now we will do. Okay, so now die sum is required greater than 7. Na? So how many time I am getting greater than 7?
That I can put it in a loop engine.
That I will write here na die sum, and just write the condition greater than 7. You will get true false true false. Okay, but true in the Python, true consider as a 1 and false consider as a 0. Means if you want to see true plus true, you will get the 2. Okay, if I do true plus false, what will be the output? No, 1, because true is 1, false is 0. Okay, false plus false, you will get the 0. Okay, so now what is the thing? Okay, this particular die sum is greater than 7. It will give the output true false true false. Okay, and I want, if I do the summation, what I will get? True only, na? Okay, so what I can write here some. Okay, in next sum.
How many times die sum is greater than 7?
Greater than 7. So that is the 4.
So false means it is not greater than 7. The condition is not being.
False means not. So now true wala if I add, then how many time I am getting the greater than 7? That is a 4162.
So why is it giving false when I'm giving the condition that it should always be greater than 7?
No. This is not like that. I did the experiment. Okay, die 1, die 2, 10 time I roll. Now, what I did, I add this thing. Okay, so addition is required. What is the criteria? If addition is greater than 7, so there may some value will be less, na? So that's why you are getting the false.
Okay.
I'm just checking here. How many value is greater than 7? So that value is 4 1.
Now I will count that value.
What you're saying is, sir, when we are giving this condition, that I understand greater than
Why
7.
are you showing me the false?
True, yeah, na, false.
Greater than
No.
7.
It is comparing, na? It is a comparison. If die is equal to 7, means if satisfy, then it will give true. So total.
Equal to, if I give the condition, it should show me the false and true together. But my condition is die sum is greater than 7. That means whatever is the sum 10,000 times, the sum has to be 6.
No, no, no. No, die means here, die 1 I'm rolling, so that is the random. Die 2 is the random. Now I'm adding. So that value, 1 lakh value I will get. So there some value will be greater, some value will be less. So that is the value actually I store at a die sum.
Right, but when, sir, what I'm trying to say, the greater than sign I'm giving,
yes.
why it is showing me the less than ones or equal to ones?
Greater.
False वाला condition क्या होगा? Less than or equal to 7, which is
Yes.
not agreeing to this.
That's yes, yes. False, na? That's why.
Why it is coming when हमने specify किया है कि greater than 7 ही दिखाओ. तो true.
नहीं, greater than 7 नहीं दिखा रहा हूँ मैं.
बताओ.
Yes, die is greater than 7. That is the condition. Okay, die sum, their total value 1 lakh present. Now first value it will check. It is a true. Then second value, true, false. Like that, you are getting the. For 1 lakh, it is means this values is a 1 lakh. Here it will not show.
No, I value I'm understanding. But like when we put it like last class में आपने वो int वाला कराया था कि जितनी बार वो match करेगा उसको वो उतना देगा. तो यहाँ वो match नहीं कर रहा है ना.
नहीं, that is a different thing. That you if I pass this particular condition in the data frame, then it will show the true. That is the Excel related analysis. So don't confuse. If
no, what
this,
I thought is that once if I'm giving a condition, the condition needs to be matched with all that 10,000 and only true will come जहाँ पे greater than 7 है.
But how you can then compare? The first one is the true and second one is false. Then how
why
you can?
The false come that it's okay that I understand.
नहीं, second means total 10 lakh value. One is the true. Second entry, that is the false. So how it will show?
So basically it is checking and giving me both.
When I write.
So अभी मुझे true वाला खाली चाहिए. That how many times it will come as true.
So that I can do with the help of sum. And there means you confuse like that. If I pass this particular thing in the DF, then I will get only true. So that is the Excel wala analysis.
उसके लिए मुझे वो data frame में pass करना है.
That is the difference.
Only that many true which will agree to the condition.
Okay, so now as per the theory, what is the output they given? Okay, there is the 15 combination that will be greater than you can say out of 36. As per the theory, there total 36 is permutation combination, and out of 15 will be greater than 7. That is the theory. So 15 by if you do 36, and you will get 0.41. But that is the theory, and here we are doing a simulation. So we are just comparing that theory.
41,623 out of. 10,000
out of 1 lakh means
1 lakh.
Yeah.
That it will be true.
So what is the value? Let me check. Now this is the 41623 divided by 1 lakh na. So you will get 0.416. So when the size is very large, you can say that theory will work. Okay. So with the help of the Python, this
theory and now it has come both simulation and that both are same.
Both are same. So they prove.
इसको कम कर देते तो फिर it wouldn't have been same. If the
then we can't prove.
I would have given like 1,000.
Then that means if size is large, the sample size is large, means you are near to the population. Means you can say you are means near to the accuracy. So if you take large data in your research, it means you are more accurate. Okay, that is it. Large data that depend on your problem definition, means how much data you can take. But अभी तो IoT and all thing digital, so there even 10 lakh also consider as a large. IoT data we will get na continuously. So that is the way.
For PhD also 1 lakh.
No, for PhD means on what topic you are doing that on the basis of. So there you can take means try to take the good data like 500 more than 600 like that. Even in my PhD I taken approx 1800. That is a product data I taken 1800. Yeah.
Product data means you had people responding to your question.
No. My topic is different. Means we try to predict the means before the production we try to predict the quality of the product.
Okay. So who the sample?
So there I taken the product and with respect to the product.
So 1800 products.
1800 product related data.
Product list, not the same product.
The same product related thing. Yeah. 1800 I taken, and there means first we identify how means what are the characteristics for the quality. Okay, and what the thing is means actually independent variable for that characteristics that we identify with the help of the literature, with the help of the expert opinion and all. And after that we taken the data from the industry and we made the some machine learning model. So that is so again that what type of the algorithm and model is we need to use, that again depend on your sample size. No, patent nahi. Only 3 article I publish on that particular one. Means all are ABDC. So okay. So now so even that data is less for the artificial neural network ANN. ANN required more data. So it depends. Okay, if you are using the means small data, then go for simple linear regression. It will also work. If data size is increased, that's why this algorithm and all the machine learning, artificial neural network is came. It means actually as per the stats you require more than 30. That's it. हाँ बस तो वो भी कर सकते हो आप.
नहीं बट
अच्छा मैं
Okay. So np dot random dot binomial, and here 1 to 0.5 means it will consider, means it will start from 0. Okay, so 0 and 1 is the, means 0 means I just assume that failure and 1 is the success, just assume that. Okay, and probability I written here, the probability is 0.5. So if I flip a coin, then what is the probability of head? 0.5. What is the probability of the tail? That is 0.5. So 1 and 0.5. Okay, and now if I again run, I am getting 0 also. Okay,
0 or 1.
0 or 1.
So it will be alternate 0 1 0 1 because
It is a random na, sometimes all random, it is not necessary always you will get.
नहीं हाँ नहीं again not necessary. It's random, right?
Now I'm getting one. So now this is the Bernoulli experiment, because only now if I do the, okay, so please our theory you need to read, means because I, okay, okay, okay. So now I'm flipping the two coins simultaneously. Okay, so what I will do in that case, np, okay, as it is. Okay, I will take this as it is, control a, control c, and now this is the thing, and instead of one, now I will pass two, means two coin I'm simultaneously flipping. Okay, means the experiment is equal to 2, you can say 2, I am simultaneously flipping the coin. Okay, so now sometime 0, sometime also you will get the 1. Okay, sometime also you will get the 2, also you will get. Okay, so like as we discussed in this experiment, 0 1 2, so chance of 0 head 1 by 4, chance of 1 head is 1 by 2, chance of 2 head is 1 by 4. This is the theoretical part, right? Here what I did, I means there is the permutation combination I made, like head head, head tail head, and tail. On the basis of that, this calculation is done. Now we try to do the simulation of this entire thing. Okay. Okay. So now this is only one time I'm doing. I have two coin and I'm flipping. Okay, one time. If I do 10,000 times, then 10,000 value I will get, right? So you can pass that number of experiment. 10,000 and 1 lakh also you can pass. Now this total value is the 1 lakh. Okay. Okay, so now I just try to make the this what is the count plot for this particular thing, and I just try to check it is matching with this theoretical part or not. Okay, so here 0, what is the chance? Only 25%, 50%, 25%, and addition always you will get the 1. Okay, so now okay, so what you need to do, you can assign this particular thing as a 2 coin. I will write just as a one variable coins. Okay, here total 1 lakh value is present, and I want to make the count plot for this particular thing. Okay, so count plot COU. Okay, and here what I need to pass, x is equal to 2 coins. Now see, this is your simulation part, but approximate you are getting the same value. This is the experimental part. Okay, and earlier what we discussed in the PPT, that is the theoretical part. Okay, now we try to see where we can utilize this thing. Okay, so that we will check. So there is the one question is like that, manufacturer has a means 12% defect in the production. They produce the some product and they are getting always approx 12% defect in the production. So I will write that particular thing. Okay, 12% defect rate in the production. Okay, and there is a buyer. Okay, so the buyer decide, means buyer will take randomly 20 piece, and if there means less than 2 defective piece, then it will accept. If greater than 2 defective piece, then it will reject. Okay,
that lot.
that lot. So that is, means now this is the manufacturer and their 12% defect rate. Okay, now they will pass this particular means assembly and whatever the thing to the buyer. Okay, now they will, means what is the means inspection policy of the buyer, they will randomly take the 20 piece. Okay, and out of 20, if less than 2 defect they will receive, then they will accept. Greater than 2, then they will reject. Okay, so that is the thing. So here
One defect.
buyer test 20 random product. 1 minute, I will pass this into the second line. Huh?
मुझे वही लगा
what is the possibility of getting accepted? Okay, कौन सा वाला? ये पूरा लाइन डिलीट कर रहा था, 2 टाइम डी. अच्छा यहाँ पे लाइन है जो इनसाइड 2 टाइम डी, आउट गो आउटसाइड एंड 2 टाइम डी.
More or less defective product, right?
हाँ डिफेक्टिव, हाँ
More or
प्रोडक्ट.
less defective product. और ये क्या है? What is the possibility of getting access?
Okay, so it is a binomial distribution. Okay, why? Because here is the two, always you will get the two output. One is the defective and not defective. So it is a binomial, you can say. Okay, so now I just want to simulate this thing. Okay, so how you can simulate np dot random, and it is a binomial distribution, so you need to pass the binomial. Okay, now how many means, what is the means experiment size, or you can say sample size here, 20, right? So I will pass the 20. Okay, now what is the probability of getting defect? 12 means 0.12. 0.12, and just assume that the total number of the means product means number of product is, I just assume that 1 lakh.
1 lakh.
Okay,
So total production is 1 lakh.
हाँ.
20 are tested, chance of defect is
12, yes. So
20 के total production is
1 lakh.
1 lakh
20 are selected.
selected and chance of
defect is 0.
no, chance of total defect in that
1 lakh is 12.
1 lakh is 12.
So what is the probability that when you are drawing 20 products out of 1 lakh, it's a defective one?
So what is the chance of acceptance, that I want to know.
So what
The-
is the
031.
What is?
ये तो array आ गया ना?
No, this is the total 1 lakh means product related. This is the means output.
क्या है अभी? Wait, I'm asking. What is this 2200?
Okay, 2 means total number means 1 minute. This is the 10 lakh total means, you can say total
production.
slot means you can say total lot.
Size of the lot.
Size of the
Size
lot.
of the lot.
Okay,
One lakh
so
is
first
100.
sample they checked. Okay, in first sample they taken the, even you can say they have a number of the product, 1 lakh product, first 20 taken out. Okay, in first 20 the number of defective is 2. Then again it will take the
Next 20.
20, again take that next 20, and just assume that he is doing, means it is not possible 1 lakh time, but I'm just passing because we can do the simulation. If that particular person do the 1 lakh time, then this is the output.
There are 3. So 3 होगा, so that means that's not accepted.
That will reject,
If
yes.
we rate and say that the first lot of 20, two rejects will be there, second lot again 2, third lot 0. This is the probability, random probability for each lot.
This is the not probability, actual output.
Actual number of defects, sorry.
Yes.
Based on the probability that we have set as 12%.
This is the means, just assume that
So
actually
if
they
you
are
divide
doing. This is the
1 lakh
simulation.
into 20, 20, 20 का lots, in every lot, what is the defect, number of defect that will be? That's what it says.
Yes,
Array
yes.
says that.
At the rate of 12%.
Okay.
Okay, so now what is the criteria? Okay, how many time you are getting? This is, I can write this particular thing is the 2 rejection, or what we can write here.
Rejection is confusing. This is like
I just save as a
ये समझ नहीं आएगा क्या है.
A में save किया ये वाला experiment means simulation.
इसका output A में आया.
हाँ, so now this is the A ना, there means entire simulation there. Now what is the thing कि okay, greater than equal to 2 ना, greater than equal to 2.
Less than equal to 2 तो accept करेगा.
हाँ.
हमने less ही लिखा है.
Greater than equal to 2?
If there are 2 or less than.
Less than, okay.
तभी accept करेगा ना जब
Hmm.
equal to
A
or
is
less
less
than 2.
than. हाँ, A is
So I will get-
less than or equal to 2.
हाँ, so I will get the output के first वाला lot, that is accepted. The second वाला is rejected. The third वाला is accepted. Like that, okay.
मेरा first वाला is rejected.
हाँ, that is random ना.
Congratulations on the customer. पहला ही
मेरा ही पहला reject.
वो दूसरा लेगा ही नहीं. मैं वापस run करूँगा.
Very good.
जब तक अरे मेरा
पहला
बार-बार
खुद है.
मेरा वाला
And then
reject.
next
But why is this for me? Every
मेरा
you run it
पहला
again.
हाँ.
When you run it again for me, every time false is coming first.
आपकी first lot
That is the random ना.
But एक बार तो true आना चाहिए.
एक लाख
एक लाख
देखते हैं ना, 1 minute मैम, we will make the this count plot. You will get the idea ना. We will make the count plot.
lot change करो.
इसको एक में डाल.
One thing, what we can do as an as make count plot ना, you will get the idea कि it is a proper one.
बार-बार false ही आ रहा है.
मेरा क्या
हाँ,
मैंने भी लिखा है आपका.
It is a random ना. अभी बार-बार में tail आ रहा है तो उसमें मैं कुछ नहीं कर सकता जब हम coin करेंगे.
This is my this is going to be
Basically, when I run A, it shows an array. But when I do that formula A less than or equal to, then you run another set of random numbers.
Nah, that it will check a value you have na. In A, it is greater than or less than. It is a checking process, and it will give, if greater than means if condition satisfied, it will give the true. Not satisfied, it will give false.
Correct. But what what I'm trying to say is that if
25,000 से
after
ज़्यादा
this formula you
इसका
run
excess हो
A,
जाएगा
then
ना?
it's quite possible that the first one which you're saying is true.
25,000
हाँ, that is a possible. So we can fix that part also with the help of the seed. That also I will tell.
फिर उसके बाद ये 3 तो will not be accepted ना. What does this graph indicate now?
So this graph indicate कि okay, this is the chance. What is the chance you will get
हाँ.
one defect, two defect, three defects?
So my chance of things getting accepted with 2 defect is 25,000, right? What is this 25? What is this?
Out of 1 lakh, there is a chance ki your 26,000
25,000
means 20 1 lakh total lot I'm taking na.
हाँ.
There chance ki there means 2 defect will be get that is 20.
25,000 में 2 defect.
हाँ.
तो वो
नहीं.
accept कर लेगा ना?
हाँ, in that case it will accept. But what is the probability that I want to know? Na?
हाँ.
So okay, that you know ki this is the condition and what I need to do if I pass the sum here, you will get the.
So can you please explain this graph again? What does it tell?
1 minute.
0, 1 to 5 to 7. What does it tell?
This is a means a value. Okay, so this tell okay that means out of that 10 lakh. Okay, first lot I taken, second, third, fourth. So the means 7,000 is the chance key you will get the zero defect. Then
Okay.
one defect you will get there. You can say out of 1 lakh there you can say 22,000
Okay.
will be there. Defect probability is 1. Then 2 like that. Their number now when I generate there's some number. So that number frequency I just putting into the graph.
That means 2 defect वाली और 3 defect वाली की ज़्यादा है.
You can say 1, 2, 3 is more
हाँ.
compared to other.
Compared to other. 7 defect वाला बहुत कम आएगा. फिर तो उसका assembly line ही defective है. अगर उसके सारे ही defect.
हाँ.
अगर 7 suppose comes at 25,000. That means out of 1 lakh 25,000 times.
The simple
defect
the
is high.
out of 1 lakh there is a chance ki 56,379 means you can say in short probability is 0.56. Acceptance chance is 0.56. So I need to calculate no na.
Again,
Means what I need to do the 56379 divided by 1 lakh you will get 0.56.
So say the probability is 50% probability that this.
Okay, so now why we need to do all this thing? We have the formula binomial distribution already done na. So now we will try to do means now what is the answer 0.56 with the help of the simulation. Okay, so now we try to do with the help of theory. Okay, so there is a binomial distribution. So I think we need to call one library that is from scipy dot stats import binom. Okay, and binom. So just import first. Okay, and now binom means binomial distribution. Okay, and now here I just need to pass what is the 2 means what the thing I pass here, the same thing I need to pass. Okay, so what I pass here 20. Okay, but here what you need to pass if you explore now in binomial 1 minute 220 0.2. What is the requirement? They written or not? CD F K and P. Okay, N means sample size, K means okay requirement. Okay, so K and P we will pass. The 2 means there. Okay, means 2. No, 2 means that is the thing na ki more than 2 less than 2. So that is the K 2 and then what is the there N na N is 20 and P there is the 0.12.
N is 20 means 20 products he will buy.
He will take.
Accept whatever.
So now
and percentage defect.
1 minute. Here's cumulative density function. Now you will get. So same thing you will get. Okay, this is the theoretical. Earlier what we did that is the in simulation part.
What is that binom not CDF?
That is cumulative density function. CDF.
Density.
I think हाँ. Even मैं theory इतना पढ़ा नहीं, but cumulative density function ही है.
What is
It's why 2 term. 2 term बोल रहा हूँ ना. It will consider 0 also, 1 also, 2 also.
Okay.
Hello, 1 करेंगे 0. इसका theory मुश्किल है.
2 means 0 and 1, right?
No. 2 they are written na 2 reject more than 2.
I see.
20 out of 20 more than 2 reject then I will reject the entire lot na.
Okay.
So here 2 means I will consider chance of 0 also, 0 defect in the lot, that also I will accept. 1 defect that also I will accept. 2 defect also I will.
0 and defect, 1 and defect, 2 and defect.
So
Point 1 is the percentage.
That is 0.56. So directly also you can calculate with one line of the code. You can do the simulation
So
also.
first parameter is telling how much is the acceptance level. 0, 1, 2, 12, 20 is the batch size of
Sample size,
जिसके अंदर मैं वो ढूंढूंगी. And 0.12 is the acceptance
Defect rate.
percentage of defect.
Probability that given na. Okay, so ठीक है. For discrete now you can explore. Now we will go
Continuous.
for this what we can say continuous.
Continuous probability.
So z score, you know that z score is useful for the continuous data only. Okay, and in discrete it is not useful. Discrete means generally there means you need to use the different distribution as we discussed. In continuous, okay,
Discretes are mostly you said that when it is fixed like binomial. The output is usually
binomial as well as uniform distribution also you will get when the means output is categorical type,
example.
like a die rolling
Dice.
1
Like
2
you
3
said
4
true
5.
false, defect, not defect.
Only defect not defect, success and failure, only two things you will get as the output, it will be come into the binomial. But if more output like 0 1 2 3 4 5 6, so that type of the thing that is uniform distribution.
Acha, that is
Even there are many more things like exponential distribution is also there when you talk with respect to the time. As a queuing theory, maybe you are aware about that, na? Poisson distribution. Queuing theory, I think in the operation research, na? One type.
that it will be
Means chance of in 1 hour, chance of arrival of the customer.
acha.
That type of thing.
आप जो
That
बैंक में
also
टेलर्स
comes under
लगाते हो,
That is the means different distribution, exponential as well as the Poisson distribution. In
example,
stats, many type of the
when
distribution.
you put a teller in the bank based on how many customers you want and what is the wait time. So basis that in bigger branches where the footfall is high, you put more tellers because you have a threshold of wait time. So you don't want customers to wait for a very long time. You have a threshold limit. Basis that you decide how many counters to put. So queuing will normally very use
generally.
होता है और every restaurant में भी होता है.
How
Okay.
many other front office you put? Maybe hour wise it will be maybe
I
morning.
think normal distribution related thing we discussed in the previous sessions also means what is the thing? Ki, first, if you means normal distribution means what mean, median, mode all are same. That is the first thing. And 50% data will lie above mean and 50% data will fall below mean. That is the thing. And it is symmetry about the center. So that maybe you are aware already we discussed. Okay. So when I convert this data into the standard scale, okay, and in that case, if I consider minus sigma to plus sigma, there 68% data will fall. If I consider minus 2 sigma to plus 2 sigma, there you can say 95% data will fall, and minus 3 sigma to plus 3 sigma, 99.7% data will fall. So that is the thing. Okay. So now it is helpful for identify the outlier also. So that's why I given the one assignment on the basis of this logic. You can make one function and you can identify the outlier if outlier is present inside the means variable inside the column. So you can do that particular thing. Okay. So now okay, what is the use of all this thing, that also we will discuss. Basic thing we will discuss, then slowly we will go central limit theorem as well as the hypothesis testing and all. Okay, so now here how to do the probability calculation inside the means for the normal distribution inside the Python. So there you need to write stats.norm dot cumulative density function. X you need to pass, and the location is nothing but the mean, and scale is equal to standard you need to pass. As we even I think we done one example also. If you have a mean standard deviation of the means you taken the one class test, and inside you have the data of the means marks obtained by the student, you calculated this mean and the standard deviation of those data. And now the thing is you want to know on the basis of that data, okay, what is the chance the student will score more than 85, less than 85, that type of so that type of the thing you can do with the help of the normal distribution. Okay, even you can means do the means height measurement of the student, and on the basis of that you can calculate the means probability, what is the chance the height will be more than 6, more less than means whatever the thing. So that you can do. So how to do in the Python, stats.norm.cdf. Okay, so that even we will do in the Python also. Now how it work, that also I think we discussed, right? So like if you have this mean value, okay, if you have the mean value, if you have this what you can say standard deviation, then you can easily measure. Means like I have a mean, I have standard deviation, and now I want to see, okay, what is the chance, this is the GMAT score data, just assume that, and what is the chance the student will score less than 70, you can measure. Means you know that what is the Z, first you need to calculate the Z is equal to x minus mu divided by sigma. What is the x is 70 minus what is the next, I think 60 is the mu divided by 10, so you will get 1. Okay, so Z is equal to 1. At 1, what is the probability that you can measure, because this is the entire area. When you make a normal distribution means curve, that entire area is nothing but the probability, and always when you calculate the entire area you will get equal to 1. So that is representing the means probability. Okay, so now if what is the chance key the student will score less than 70, means that is the left side area. If you calculate the left side area, you will get the answer that you can calculate with the help of the Z score, and in Python directly you will get the answer. Okay, so we try to, okay, we quickly try to do this thing, and even we will take the one case also, stock related case we will take. Okay, okay, so now how to means to do this normal distribution calculation, that we try to see stats. Okay, first we need to import this stats. Okay, so import scipy dot stats as a stats. Okay, and after that we can do this stats and dot and press the tab, you will get the normal distribution option norm. Okay, then dot cumulative density function and pass means it will give the entire area left side. Okay, so now just assume that I want to know 85 means how many student will score less than 85. So always it will give the left side area means less than value. Okay, probability of less than. So 85 less than 85, how many means what is the chance the student will score less than 85, that I want to know. So 85, and how to pass the mean with the help of the location. Okay, so that is the 70, and one more thing I need to pass, that is the scale, and scale is nothing but you can say standard deviation means that is just assume that 12. Okay, so you will get the answer ki their chance the student will score less than 85 is the 89%. Okay, so like that we can measure the normal distribution related. Log means mean.
Location of the mean.
Log
Value of
mean. And scale means the standard deviation you need to pass. Okay, so now we try to take some Bombay Stock Exchange related data. BSE. I think what is the website? BSE only, na? Bombay Stock Exchange. Live stock share market. Okay, so we can compare the two share means that means in which share is the more the risk is in which share more return we will get. That type of the thing we try to do with the help of this means what you can say normal distribution. If we take the gain, okay, so that will follow gain is follow the normal distribution, because sometime gain you will get positive, sometime gain you will get negative. So it is means the value you will get means near to the mean and it will fluctuate. Okay, so let's see means what type of the distribution and all thing. So I will try to compare two company. What the company we can pass? IDFC and okay. The IDFC first we will take. This is the IDFC, and when you search IDFC, go to the archive, and here you can pass the date means for CSV file actually I required in the Python. Na? So I will take from 21st to 19 because 2 days the Saturday. Na? That how many month? 21/7/2023. Even we will take 01 pass. Yeah. First July, or even we can pass first Jan. Take data from first Jan. Huh? First Jan to 19. Okay. And I required daily data. If I shift this one here, I required the daily data. Now if I submit, okay, submit, and now this data you will get here. All the data you will get. This is the CSV file. Even in the download means here you will get this downloading option, and here also you will get the download option. So just click on download. This is the downloading option. Okay, 1 minute I will see. So IDFC CSV is saved. Okay. Now I will take another ICICI and we will compare. Okay, ICICI. No? Okay. So now this will I will save with the name of ICICI Bank. ICICI Bank. Okay, and just click save. So that CSV file will save in your local system. So we have two files now, ICICI and IDFC. So now what we can do, okay, so pd dot read underscore CSV, and that file is available inside my download. Na? So I will go to the download and that location only I will give.
This is my C drive.
Any location you can give. So now IDFC, so I will take the location of the IDFC.
Change the name here in Jupyter.
Nahi.
No, but then I have to keep it here for Mac to access.
So now if I right click now, I will get the copy path option. हाँ टाइम क्यों हाँ मैंने राइट क्लिक किया थोड़ा टाइम ले रहा है मेरे हाँ ठीक सो नाउ कॉपी एज अ पाथ and just paste that particular path, and sir also suggested me one option. Now if I pass the arc, then no need to change the slash. So then I think you will get the answer. So that I checked at home and it working, so that is the better. कहाँ पे आ रहा है
ये जब pd dot read underscore csv करके डाल रहे हैं बात
syntax error means you missed the comma. हाँ syntax means some comma rename कौन सा करना था
अरे मैंने तो एक ही करा HDFC.
Okay, so now LDFC, one more data, that is the, I think, ICICI, right? So what I will do, I will copy this entire thing and I will change just ICICI. That is the only requirement. Instead of this, ICICI, ICICI. Okay, done. Just change the name. Means that is the means in the same location that file is available, na?
HDFC को HDFC करते हैं, ICICI को ICICI करते हैं. What do you say?
What is this first sentence?
HDFC and ICICI both ना.
Yes.
एक ही उसमें कर सकते हैं ना. You don't have to have another roles.
You can do, means once you will get the means hands-on good means practice, then you can write entire thing in the one line. When we need to do the deployment, we need to write 200 300 line in the one cell only. So this is the initial means initially you can do with the help of the Jupyter notebook. After that .py and we need to do in the VS Studio many analysis. तो वो थोड़ा एडवांस हो जाएगा, but ठीक है. VS Studio, and there for deployment purpose we use. So there means all the thing you need to write in one cell only. First we need to check here, then put in the VS Studio. Okay, so now what we can do here, what the thing is required in this entire thing, I'm worried about the gain. Okay, so what is the gain? Gain means you can say the close price of today minus close price of the yesterday divided by close price of the yesterday. With the help of that you can calculate the gain. So I need to create the one cell that will represent the gain of the stock with day wise. Okay, so that I try to do now. So okay, even first check the means shape of the both means ICICI as well as the IDFC, because both same shape is required. Okay, then only we can compare, because that's why we taken the date also same. Okay, IDFC and CICI dot shape. Okay, so both are same in my case. Okay,
हमारे केस में 166 and 30. तुमने HDFC रखी नहीं थी.
okay, okay. More thing, their total number of the column is the 13, but I am not required the 13. I am worried about the gain only. So what I will do, okay, so this is the IDFC is the your data set. In IDFC I am worried about the date as well as the close price, because with the help of the close price I can calculate the gain. Okay, so I will use these two only. Means two I need to call. First one is the date, so I will call the date, and second one is the, you can say, the close price. So I will write the close price. Okay, so these two only I require, and that now I will save this particular thing, because I don't require that 13 column. I will save this as a, means I will update this variable again. IDFC I will update.
एक जगह पे single inverted comma, एक जगह पे double. Is there a significance to that?
No, means you can pass single, double, it will not
There's
impact.
not going to be any difference. Okay, then just wanted to do that.
Okay, so now I in IDFC I updated the HDFC data, and there are only two column present. One is the date and one is the close price.
Yes.
The same thing I want to do. The same thing I want to do with what? ICICI. So just change the, instead of HDFC, pass the ICICI.
Done.
Okay, so now we will calculate the gain also, but before that, okay, type of the data is proper or not, that I want to check. Okay, so in IDFC, what type of the data is present? So IDFC dot, how to check the type of the data? D types, right? So if I pass the D types, the date is nothing but the object, and the close price is the float. So close price is okay, but date is object, so that I need to change as a date format. Okay, and otherwise it will consider as a nomenclature data, so it will not work. So how to change this particular data set into the means date format, that we can do with the help of the this, what you can say, with the help of the PD.
Data type पता क्या है कि दो हमारे columns हैं और data type क्या है? One
हाँ.
is considered as
नहीं, what did we do with this HDFC is equal to HDFC date and goes with both
दो column.
Only the two column I want, that's why.
Inserted two columns.
There 13, there the total 13 column present, but I'm interested in this two.
Okay,
So I taken these two and updated again IDFC.
No, I'm not getting what.
The-
Because date and close price is there already, right?
this now I want to change this date. So okay, how to do that particular thing? So PD dot, there is the date time index is available. With the help of that we can do. So I there miss date time index. When you press the tab, you will get the idea. Okay. Now what I want to change into the date time index, I want to change this date, right? So how to pass that particular variable? You first need to write the data name IDFC, and in the IDFC I want to change this date, right? The double quote, single quotes, that is not matter. So now means all the thing is available in the date format. And now this particular thing, now all the thing is available in the date format, and this particular thing I want to update where? At date.
Yes.
Okay, so what I will write now, I want to update here now, so I will take this one. I want to update all this thing at a date. Can I run now? And now if you see IDFC data type, you will get the date time. Earlier it is object, but now it is a date type.
whole HDFC date के अंदर
Hmm.
date time index. What is date time index doing?
Earlier it is object now, so I'm converting into the date.
Object, right? Where it was date.
Earlier it is object.
हाँ, ये जुलाई का बच के. तो अभी now it is totally numeric type. This is object.
So I know that the same thing will be present in the ICICI also. So I will not check, but I will convert that also into the date. So what you need to do, just type instead of IDFC ICICI, and here also you need to type ICICI. Done. And now if you check, you will get definitely that same thing, a date, time, and the float.
Right?
Access 1 means column. Okay, so here 0 means row. So now IDFC dot set index, and it will set the date as an index, but already date wala column is available inside. So that's why I need to write okay dot drop, and what you want to drop, this date wala column, and access is equal to 1 means it indicates the column. Okay, so now data is more proper. So this data means cleaning part you need to do when you get the in your research some data, you need to do some data cleaning part, and that is there is no fixed pattern. You need to see what type of the thing is required, means what type of the data is required, is there any duplicate present or not. And there many column will be available, so what column is useful for you, so that all the thing you will get, and you need to identify as on the basis of domain knowledge and on the basis of expert opinion. So now I will pass this one. Okay, so I will update this again. This is the IDFC, more clean data. So now again I will update on the IDFC only. Okay, the same thing I will do with the ICICI. Done. Okay, so now what we can do, that gain we need to calculate. Okay, so now this IDFC, if I call this is IDFC data, inside this data I want to calculate the gain. So how you can calculate the gain? Suppose I want to know, okay, what is the gain at 1st September 23. So what you will do, you will take 1574 minus 1571 divided by 1571. So means what is the means current stock price minus previous day stock price divided by previous day stock price. So okay, that we can do with the help of the percentage change. So here I will pass the close price. I'm interested in the close price. Okay, this is the close price, and now here indexing you will get by default means 0 1 2 3 already we removed, and now we pass the indexing is the date time. Okay, so now here what I want to do with the close price, I want to do the PCT change. That is one option is available, percentage change. Okay, and here I will pass period is equal to 1 minute, periods is equal to 1. Okay, minus 1 actually, 1 minute, reverse we will go now. Okay, so you will get the this particular thing you can save as a gain. This is a gain. Even you can see if you do the means manually, means if you do the calculation you will get the same value, minus 1, because I want to subtract with the previous day value na, so that's why I pass the minus 1. Okay, so now this particular thing I want to add inside my data set, right? So how you can create the new column IDFC and write the new column name. So I will write the new column name is equal to gain. And now if I run, so if you call what I say ITFC, so in ITFC you will get the one more column that is a gain. Yes. Okay.
What is the output is giving the 0, 1, 2, 3 is coming out.
0, 1, 2, 3.
Yeah, this is the first one which you get. HDFC is equal to HDFC. And you're passing that into where
This I pass into the new column. I create the gain new column. Same thing. Now I will do the same thing for ICICI. So now I will pass ICICI. Okay. So now if you call ICICI, you will get the plt dot plot, and here what the thing I will pass, only gain I will pass. Okay. So there is the one is the ICICI. Okay, even you can directly write the gain also, dot gain, or you can use the square bracket and pass the gain. Both the option is available. So now if you run, you will get the graph. Okay, for line plot. दोनों को साथ में करना है, then pass both the thing in the same cell. Okay, now IDFC dot gain, and you will get the both graph together. Okay, so now you can even see where is the more variance. More variance is present, I think, in the second IDFC, that you can visualize. Okay, now the thing I already discussed, you can put the first one is the blue, second one is the orange. How you know? So now what you need to do for that, you need to pass the legend as we discussed in the data visualization lecture. No? So now in the legend, there I can pass the, what is the first one here? ICICI. What is the second one? Is the IDFC. Okay, so now you can see even graph is small. I want to increase the size of the graph, that also you can do. So how you can do that particular thing, you can do with the plt dot figure. आ गया ना? Okay, 1 minute, I need to pass as a one variable. 1 minute, sorry, it is. Now you will get see, you will get, because you need to pass as a single variable, so use the list for these two things. Okay, now here now I just try to increase the size of the this graph. So plt dot figure, and I will increase the fixed size. So this thing I think we discussed in the data visualization part now. So 15 and I pass the 10. So now graph will be bigger, and you can means more visualize the thing.
पता है बड़ी peculiar problem है यहाँ पे 90 automatically 1970 ले रहा है पता नहीं डेटा तो सेम था
Distribution plot I want to make for the IDFC, for ICICI, it will give the idea how means particular share gain is vary with respect to the center. Center obviously will be 0 for everyone, because sometimes it will go up, sometimes it will go down. So approximate 0 you will get. So okay, let me check SNS dot what is the distribution plot, and here I will pass this first IDFC dot gain. The second one I will pass SNS dot displot, and ICICI dot gain. Okay, so it will make the means distribution plot for both, and combined plot you will get. And maybe if you face any issue, then we try to make the same issue you are एक ही दिख रहा है दोनों एक ही सेल में पास किया आपने
दो अलग अलग इनफैक्ट दो आए हैं आई गॉट टू
सेपरेट
मेरे को एक ही
सेम कलर और
और
सेम कलर
HDFC दिख रहा है अगेन इट्स नॉट शोइंग एसएनएस दिस प्लॉट इट्स नॉट शोइंग ICICI
तो इसका ठीक है
दिखा दोनों रहे हैं बट सेपरेटली नॉट इन द सेम सेम
मेरे को एक ही दिखा रहा है सेपरेट व्हाई इज इट वेरिड ऐसे क्यों हो रहा है
वो libraries means develop for the in your case
लेजेंड डाल के करें कि दोनों एक ही में करें और ट्राई करूं लेजेंड डाल
हाँ that you can pass PLT legend and try to
कभी एक में दिखाए आई कैन ट्राई दैट नो
हाँ।
ये शॉर्ट
तो
आल्सो दोनों
लेजेंड
कर
के साथ ही किया था ना
नहीं पिछला वाला ये वाला क्या
ICICI HDFC डॉट गेन तक
This one.
हां
नहीं सर अभी दो अलग अलग दिखा रहा है
इसका फिर
इनफैक्ट इसके ICICI दिखा रहा है दूसरा लेजेंड दिखाई नहीं रहा है
1 minute I will check इसका क्या
आपको लगा दिया आगे वाला
नहीं मेरा हाँ
आपको लगा दिया
नहीं वो कैंसिल किया आज का नहीं है इसलिए ठीक है चल जाएगा 1 minute I will search on the this sorry plt dot figure, and here you can pass the fixed size is equal to 15 10 like that you can give, so it will give the proper graph. Now you can see I think 15 5 will be better. 15 2.5 will be better. हाँ ठीक है.
मुझे नहीं लग रहा है ये आ रहा है.
नहीं आ रहे दोनों ग्राफ.
नहीं HDFC गेन के नीचे
नहीं आ रहा है ना. अभी ICICI पास करो तो ICICI का ग्राफ है वहां पे जाएगा वो. Now ICICI and this is related to IDFC. Okay. Okay. So now which share is the better? How you will means.
हम तो अभी कर ही नहीं सकते, हमारा तो पूरा गड़बड़ है.
Okay. Then see and I will share the recording and all thing.
Yeah, now
We
forcing
can
me.
continue to put the codes there, and then once he gives
Ah, yes,
the
हाँ.
link, once he gives the file,
Yeah,
then
just run it, yeah.
Okay. So now the next how
HDFC
I.
गेन के नीचे HDFC लिखो टाइटल
Okay. So which one is the better? How I can conclude कि which one is the better?
और ICICI के नीचे ICICI.
So first thing you can do okay, on the basis of this is the historical data. Okay, so I will identify the mean and standard deviation of the both the thing. Like first one is what I think ICICI. Okay, and ICICI dot gain dot mean. Okay, so if I calculate, I will get the mean, and that I want if I do the round of this particular variable with 2 and with even 4. Okay, you will get the 0 because approx 0. Okay, so this is the you can say the mean of gain of ICICI. This is the variable, right? ICICI gain or mean, and that I round by 4 because a lot of value I'm getting now after decimals. I want after decimal only 4, and you can print this particular thing. Okay, like here you can write key what we can write mean of ICICI. Okay, done. Mean of ICICI. Same thing now. I will control C and I will paste here and I will write here a standard deviation STD. STD standard deviation, and here instead of mean what I will write STD. Okay, so now you will get the standard deviation as well as the mean for this ICICI bank. I want to do the same thing for IDFC. So what I will do, I will change this particular ICICI with IDFC. IDFC here also I will do the some changes like IDFC. Here also I will do some changes IDFC, HDFC, and now. So can you tell me? Means mean is okay. The variance is represent the. Okay, so when we talk about the stock market, more variance means more risk. Okay, so a standard deviation actually represent the variance. Okay, so when we talk about the this ICICI and IDFC, where is the more risk in IDFC? On what basis?
Because standard deviation
Is more.
is more.
Okay, compared to the ICICI. That is the one conclusion. Okay, now the next I want to know. Okay, what is the chance? Someone want to know. Okay, what is the chance? I will get means what we can say more than 2% profit. What is the chance I will get more than 2% profit? Okay, you have a graph, right? This is a distribution graph. This is nothing but the 100% probability. Okay, so more than 2% means where you can say this one, na? How you can represent that particular thing? 1 minute. Okay, so more than 2% means what I will say. Okay, in if I pass the CDF, I want to see. Okay, x is equal to suppose 0.02. That is the thing. Location, you know. Location means what? Mean. Mean you know, as well as you know the scale. If you know all these three things, you can calculate the probability, right? You can calculate. Now we try to do that part, and if that is the theory also, you need to check the theory part also. And I quickly try to complete this case because again, okay, what we can do? Stats dot. It is a normal distribution as we know. Okay, it is a vary with respect to the mean only, and it's follow the normal distribution. So I will pass the norm, and there is a cumulative density function. And what I will pass, okay, just let me know if 0.02 is the means profit, right? 2% profit. What is the chance ki 2% profit? Okay, so I will pass 0.02 is the location. Means you can say X. Now location I will pass. I'm sorry, that is the 0.02 is the X. Now location is what? Location you know that you calculated already. This is the mean is the location. So you can pass this as a means I want to create the thing dynamic. So I will pass. Huh? Because after decimal I want only 4. Round inside the round I pass. Na? In round, if you want to round anything, so what you need to do? Write round, then pass the value, then how much after decimal you want. Okay, so I pass the variable only. Okay, this is the location, and now what is the scale? So in the scale, I will pass here STD. Okay, so now it shows 97, but always you will get the area left side. Okay, I want to see what is the chance it will create more than 2% profit means where I want the location right side, right? The chance, what is the chance there? You can say how much chance? 0. If I multiply with the 100, 2% chance, na? 0.02, 100, 2%.
Sorry, this 0.02 that you put in the front, what is that?
2% profit, right? 2%
Chances
means,
of 2% profit.
so 2% means 0.02. Okay, so 0.02, suppose I will get here, na? And more than 2% I want, na? But how much probability there it will create more than 2%? So more than 2% means area right side. So area right side means 1 minus I need to do. And how much chance there? 2% chance it will create more than 2% profit. The same,
1 minus for the area right side.
by default it will consider left side area. And we want greater than. By default it will consider 4 less than. What is the chance to
It will be what we consider. It will consider
normal distribution means here na. So by default always when you do the CDF it will consider the left side area.
which is the normal distribution.
In normal. But we want right side area na, more than.
Minus. Left side is plus 1.
Left side. Total is 1.
हाँ.
In the stats lecture part they will
Lecture
explain.
part, हाँ.
तो यहाँ कितना बचा? तो ये टोटल वन है, टोटली वन है। तो वन माइनस ये करेंगे ना। अगर नहीं करें तो obviously इसका opposite है।
Opposite means how much chance I will get the less than 2% profit? That answer. Okay, now the same thing I want to do. Okay, here and I want to do for IDFC. So it will give me the idea. Okay, IDFC. Here also I will pass the HDFC. And now if I calculate how much chance here, it is 3%. So now you can say okay, if I invest in the IDFC, then more chance I will get more than 3% profit compared to the more than 2%. I'm sorry, compared to the ICICI, that you can say. Okay, so now we are talking about the this all the thing is talking about the profit. Let's explore the loss wala part. Okay, so now the same thing you need to do when I say the loss means what will be the x value minus 0.02 left side, right? So here I will pass minus 0.02 and by default it will show the area left side only. So no need to do the 1 minus. Okay, so here what is the chance? 1.6% chance. Okay, so ICICI you can say more safe compared to the ITFC, but also there you will get less gain compared to the ICI. Okay, that ITFC, and if I run here you can see the loss chance is also more. Here profit chance is more, then obviously loss chance is also more. That you can do.
Because 2% increases if you invest and expecting 2% the next day, correct?
Now, what is the thing? This conclusion is not means final conclusion because we taken the some limited data means it is a sample data. On the basis of that, you can't draw the conclusion. Okay. So for that, if you want to draw the conclusion, here I can't say the IDFC is better, ICICI is better for profit and all thing on this small data set. For that, you need to do the inferential stats like hypothesis testing, T test, Z test, all the thing we need to do. Then we can draw the conclusion for entire means population. Means you can say okay, IDFC is better or this better. That we can draw. It is not a means generalized answer. This is on the basis of data. Okay. But if you want to means give the generalized answer, then we need to go towards the inferential stats. So that we will explore in the next session. Okay.